Hi, I will introduce you to Kirchoffs law. So the first one is a Kirchoffs Current Law, also known as KCL. So this law states that if we have a node, okay, this is a node, okay, and these are current I1, I2, I3, I4, I5. So this law states that the current entering a node is equal to the current leaving that node. So a more basic definition for this one is that the Kirchoffs current law states that the algebraic sum of the currents into a node at any instant is 0. So if we have I in, the sum of I in is equal to the sum of I out, basically. So the sum of I in is I1 plus I3, and the sum of I out is I2 plus I4 plus I5. Okay, very simple. Now let's look at the Kirchoff Voltage Law, also known as KVL. So this states that the algebraic sum of voltages around any closed path in a circuit is identically 0. So if we have a closed path, so this is a closed path, okay, so let's suppose this is a source, let's call it V3. This is a resistor, let's call it R7, and here is the V7, the voltage across the resistor, and let's call this one R8, and this is V8, and let's call this one R9, and this is V9, the voltage across R9. Now, by the definition, if we add all the voltages, and this should give you 0 around the closed path. So if there is a voltage in that direction, for example, let's call it VB. So if this voltage is in the other direction, when we add, we have to add the negative value of the voltage. So minus VB plus the other. So this will give you 0. The sum of all the voltages is 0. Okay, so this one is for the VB. So these are two Kirchoff's laws that will be used in electric circuits. Okay, now let's see resistance. So if we have two resistors connected in series, let's call it R1 and R2, now a current flows through that series, and let's call it I. So the same current will goes into R1 and the same current will goes into R2. So if we have to find the effective resistance, so we can replace this by one large resistor, okay, we call it the effective resistance. Now the effective resistance would be R1 plus R2. So it is a sum of all the resistors. So if we have R3 and so on until the last one is Rn. So we have to add every single resistors until the last one. So this is the effective resistance for resistance in series. Now for resistance in parallel, it's a little bit different. So suppose we have R1 and R2. So now the effective resistance would be 1 over R effective would be 1 over R1 plus 1 over R2. Okay, this is the formula for resistance in parallel. Okay, so this one is for resistance in series. Now we can simplify this. Okay, so we cross multiply. These are two fractions. So this, when we cross multiply, we'll have R2 plus R1 divided by the product, R1 times R2, and this is 1 over R effective. And therefore, to find R effective, okay, it is just the reciprocal of this term. So the reciprocal is R1 over R2 divided by R2 plus R1, or we can write it as R1 plus R2. So this is effective resistance. This is just the product divided by the sum. Okay. Let's see an example on calculating resistance. So here we have a circuit. We are asked to find, without calculator, the resistance between node A and B. Okay. So to start, we have to assume that a current flows from A. So it is entering the node at A and it is leaving the node at B. So now the path of the current, when it enters node A, it must leave here and it must go to the branch over here. So the same current would go over here and again reaching C, part of it would go through the branch at 4 ohm and the part of it would go towards the 6 ohm. And the same current would go toward 4 and 2 ohm resistance. So if the same current flows, meaning that these two are in series. So if these two are in series, we can just simplify the circuit. So we can draw it again, but now we have 4 plus 2 in series, which is 6 ohm, and here is F, this is 6 ohm, okay, we have simplified this one. Okay, and now if there are different current in each of these branches, meaning that these two are in parallel to each other. So these are in parallel. So to do this parallel or effective would be the product divided by the sum. So 6 times 6 divided by 6 plus 6, 36 over 12, which is 3 ohm. So we can simplify the circuit further by writing this as 3 ohm from C to D, and we also have 2 ohm over here, and we have 1 ohm resistance over here, and this is point B. So now this is replaced by the 3 ohm. Okay, the current now would flow in the 2 ohm resistance, and it would go, the same current will flow to the 3 ohm resistance and then back to the B. So if the same current flows, this is in series. So in series, it is 2 plus 3, which is 5 ohm. So this can be replaced as 5 ohm from A. So this is a 5 ohm. This is a 1 ohm. And this is a B. Okay, now we have simplified this circuit. Okay, these two resistors are now in parallel. Write it parallel. And therefore, it is the product divided by the sum, which is RAB. Okay, this is 5 over 6 ohm. So the resistance from node A to B is 5 over 6 ohm. Okay, now let's try another example. So now we take the same circuit, but now we have to find the resistance between node C and D. Okay, to do that, we have to assume that a current, let's erase this one. We have to make sure that a current enters the node C and then it leaves at the node D. Okay, this is a current entering C, so it will flow in this branch and in this branch and in this one. So the same current I would go to the 2 ohm resistor and the 1 ohm resistor, meaning that these two are in series because the same current flows, and the same current will flow through the 4 ohm and the 2 ohm resistor, so meaning that this is in series. So we just have to add and simplify the diagram. So let me simplify the diagram. See, we have 6 ohm, and here we have the 4 plus 2, 6 ohm, and here we have the 3 ohm. Now remember that here we have 3 resistors in parallel. So first one, let's take the simple one, which is the 6 ohm resistance. Okay, so they are in parallel. It is just the product over the sum, which is 36 over 12, which gives you 3 ohm. So this is just 3 ohm. So from C to D, I can just replace it by a 3 ohm, and we have this of another 3 ohm over here. So now it is very simple. We have 2 resistors in parallel. We just how to calculate the product divided by the sum, and this is 9 over 6, which will give you 3 over 2 ohm. So 1.5 ohm resistance.